A very good morning, student. We'll start our lecture 6 on soil moisture constants. These six soil moisture constants are very important with respect to exam point of view. Why they are called as constants, why it is measured, how it is measured will be dealt in today's class. Soil moisture constant, it is called as constant because it is expressed under certain standard conditions. What is those standard conditions? We'll deal with the individual observation as referred to be as a soil moisture constant. They are used as a reference point for the practical irrigation water management, and the use of these constants together with the energy status of the soil water gives you a useful knowledge. See, when we call the soil moisture constant, it is measured under certain standard conditions. As when it is measured under standard condition, becomes a reference point, a point for other comparison. For an example, a topper student. Why is he topper? Because he got the highest marks, and that acts as a reference point to compare with other students, right? In the same way, here we are using soil moisture constant. It is a standard point. This is a condition, field capacity condition where occur after 2 to 3 days of the draining of water. This is a standard condition. Maximum water holding capacity is condition of the soil when all the pores are filled with water. So such standard conditions, so we call it as soil moisture constant. There are 6 soil moisture constant. The first is maximum water holding capacity. We also call it as saturation. The second is field capacity. And the third is permanent wilting point. Fourth is hygroscopic coefficient. The fifth is ultimate wilting point. And the sixth is moisture equivalent. We deal individual soil moisture constant. The first is maximum water holding capacity or maximum water holding capacity or saturation capacity of the soil. As the name itself indicates, under this condition, both the pores are filled with the water. How much extent to the quantity of water can be held in the soil is dealt with the maximum water holding capacity. The soil moisture tension at this condition is 0. In the last class we were studying the figure where under saturated condition the bar tension is 0. Further at the field capacity it is 0.33 bar. Here it is. The soil moisture tension at this condition is 0 as water is held in equilibrium with the free water because all the pores are filled with water. There is no girth of water. This condition becomes the saturation and the tension is 0. Just remember, if you have water is there, so there is no tension, so 0 tension. The next, excess water above saturation capacity of the soil is lost from the root zone. It is a gravitational water. So gravitational water is seen under the maximum water holding capacity condition. The macro pores, we call it as non-capillary pores. The diameter of these non-capillary pores is more than 0.06 mm in diameter, and the micropores, we call it as capillary pores. The diameter of the capillary pores is less than 0.06 mm in diameter. So in a well granulated silt loam soil at optimum moisture for plant growth, the total porosity should be 50%, that is 50% by air, 50% by the water. So under the maximum water holding capacity, both macropores and micropores are filled with water. This is a condition not suitable for the crop condition. We can compare, this is a standard point for the comparison where all the pores are filled with the water or saturation capacity. The next is field capacity. It was given by scientists Israelson and West. What is field capacity? It is a condition of the soil after 2 to 3 days of complete irrigation when most of the water is drained out from the soil. Here it is. The amount of water held in the soil after excess water has been drained away and the rate of downward movement is materially decreased. If you see here, the saturation when all the pores are filled with water, the macropores and the micropores are filled with water. But in field capacity, the macropores are not filled with water. The micropores are only filled with water. This is a condition after 2 to 3 days of complete draining. So the tension under this field capacity is 0.1 to 0.33 bar, and we consider it as a very important upper limit of available plant moisture. Upper limit of available soil moisture. And which is the lower limit? It is permanent wilting point. It is the upper limit where water is available for the plant to uptake. Even under the saturation condition, plant cannot uptake the water. But it is a field capacity condition where plant can uptake the water. That's condition we call it as upper limit. And water moves in any direction but always in the direction of increasing tension. Water always moves in the direction of increasing tension, decreasing potential. Remember this term for competitive exam point of view. Water moves in the direction of increasing tension, decreasing potential. And the field capacity of clay soil is higher than that of a sandy soil, because clay soil, the micropores are higher as compared to that of sandy soil. So just compare this figure. Saturated condition, all the pores are filled with water. Field capacity condition, only micropores are filled with water. Permanent wilting point, here you can see no water is held in both macro and micropores. Water is not available for plant to uptake. Further, the third constant, that is permanent wilting point, which was given by bricks and shands. What field capacity was given by Israelson and West? It was given by bricks and shands. The condition of the soil where water is held so tightly by the soil particles that the plant root cannot no longer obtain the enough. Here it is a condition where waters are not there. Water is not there in both macro and micropore. So plant cannot absorb the water from the soil. We call it as permanent wilting point. And the moisture is held at what tension? It is held at 15 atm or 15 bar, or it is 1.5 megapascal. Just remember, 1 bar is equal to 10 megapascal. 10 megapascal is equal to 1 bar. So the permanent wilting point, it is considered as a lower limit as discussed. And how to calculate, how to find the permanent yielding condition of the soil? We use a technique called as sunflower technique, where the field condition permanent wilting point is determined by growing an indicator plant. Which is the indicator plant for the permanent wilting point? It is sunflower. And laboratory, pressure membrane. In laboratory condition, we use pressure membrane apparatus. Pressure membrane apparatus can be used to determine the moisture content, that is in 15 bar. In laboratory, we use permanent, that is pressure membrane apparatus. In field condition, we use sunflower technique or growing of sunflower to determine the permanent wilting point. We discuss how it is. Suddenly, the sunflower will dry earlier as compared to that of other plant, because of that it acts as a sunflower water indicator, the moisture girth indicator. The next coefficient is hygroscopic coefficient. We were discussing in that figure that hygroscopic water is held at 31 bar. So water is held very tightly that plant cannot absorb. And in order to remove this water, it can only be done if you are placing it in an oven at a temperature of 100 degrees where water gets evaporated. So hygroscopic water, defined as amount of water that soil contains in its equilibrium with the standard atmosphere at 98% relative humidity at a room temperature. In other words, the amount of moisture absorbed by the dry soil when placed in a contact with the atmosphere is saturated with the water vapor of 100% relative humidity at a given temperature. The matrix section of soil at the soil moisture content is 3 megapascal or 30 bar. Remember, 3 megapascal or 30 bar. Ultimate wilting point is the fifth soil moisture content. See, we discussed permanent wilting point, that it is a condition at a bar of 15 bar soil moisture tension. If you irrigate, the plant can regrow. That is the condition of the soil. There is another two terms there, temporary wilting point and permanent wilting point. In permanent wilting point, if you irrigate, it will regenerate. But there is a condition called as ultimate wilting point. The plant cannot take any moisture and die eventually. It will die. It is held at a tension of minus 60 bar or 6 megapascal. Then there is another term called as moisture equivalent. It is a sixth soil moisture constant. What is moisture equivalent? The amount of water retained by the initially saturated soil after being subjected to a centrifugal force of 1000 times that of a gravity for above half an hour. We call it as moisture equivalent. So, and if you consider a soil sample, if you have placed it in a centrifuge and applied a pressure equal to 1000 times of a gravity for half an hour, 30 minutes. So after that, measuring the moisture content in the soil. Under such condition, for sandy soil, field capacity condition, moisture content is more than the moisture equivalent. For silt soil, field capacity is equal to the moisture equivalent, and for the clay soil, field capacity is lesser than the moisture equivalent. This is a standard condition. If you are taking a soil and subjecting to the centrifugal force of 1000 times that of gravity, if you take the sandy soil, the under field capacity condition, the moisture content will be higher than the moisture equivalent. If you take it as a silty condition of the soil, it is really equal. But for the clay soil, the field capacity condition has lower moisture content than the moisture equivalent condition. So this is about the soil moisture constant. If you are liking my teaching, please subscribe my channel and hit a like button. Thank you.